2.3 part 2. So we're going to continue to do the same stuff that we did in part 1. We're doing a lot of synthetic division again, but we're kind of going to apply it to different things now. So synthetic division can tell us quite a few things with our polynomial. We're going to be finding different things than what we did in part 1. So the first thing we're going to talk about is the factor theorem. This states that if you have a binomial, so that it uses x minus k as an example here, and you use synthetic division, if the result is 0, then that x minus k is a factor. So this box here is for the remainder theorem. It's not the factor theorem. But factor theorem just says that if you do synthetic division and you get a remainder of 0, then it's a factor. So in example 6, it says show that x minus 2 and x plus 3 are factors of our polynomial here. So to show that they're factors, we need to do synthetic division. So inside the box, I'm going to put my coefficients. So 2, 7, negative 4, negative 27, and negative 18. Double check, make sure you're not missing any terms here. We don't have to put a 0 in any spot, so we're good there. Now let's check to see if x minus 2 is a factor. What am I going to put on the outside to check and see if x minus 2 is a factor? 2. Awesome. We changed the sign. So I'm going to put 2 on the outside. So drop down to 2. What do we do on the outside? Multiply. 2 times 2 would be 4. Plus 7 would be 11. Times 2 is 22. Plus 4 would be 18. Or plus negative 4. 22 times 18 would be 36. 36 minus 27 is 9. 9 times 2 is 18. 18 minus 18, 0. So our remainder is 0. Does that mean that it's a factor? Yep. So I can put a check mark. X minus 2 is a factor of our polynomial. Now let's see if x plus 3 is a factor. So instead of going back to our original polynomial that we started with, I can take my coefficients of my answer and see if x plus 3 is a factor of this. If it's a factor of the answer, it means that it was going to be a factor of the original. So now I'm going to do synthetic division again, but I'm going to put 2, 11, 18, and 9 inside the box. Now for x plus 3, what would I put on the outside? Negative 3. Awesome. We changed the sign. So negative 3 goes on the outside. Drop down the 2. Multiply outside. You get negative 6. Add 5. Multiply. Negative 15. Add 3. Multiply. Negative 9. Add 0. Is it a factor?
Yes.
Yes. When you get 0 as the remainder, it is a factor. So x minus 2 and x plus 3 are factors. This says find the remaining factors of our function. So to find the remaining factors, we're going to use our answer. We can't factor this whole long thing. So we're going to use our answer to now factor. If my question started with x to the 4th power, my answer here would start with what? X to the 3rd, 1 less. And then what would my answer down here be? X to the 2nd. So I have 2x to the 2nd plus 5x plus 3. Let's factor this. 2x squared plus 5x plus 3. How would we factor? Awesome. Multiply the first times the last. 2 times 3 would be 6. What are 2 factors of 6 that add to 5? 3 and 2. So this factors into x plus 3 and x plus 2. What do we have to remember if we multiply the first times last? Got to divide by that first number. So don't forget, if you multiply the first times the last to factor, you have to remember to divide. So when we divide, what do we do if we can't divide? Awesome. Put it in front of the x. We have 2x plus 3. And then if you can simplify, simplify. What's 2 divided by 2? So x plus 1 would be our remaining factor. Now, these two are factors. If this question was on the homework and it said write it out in complete factorization, what else do I know is a factor? Awesome. X minus 2 and x plus 3. The two things that I had to show that were factors in the beginning, those are also included in my factors. So if it said write out all the factors, this would be our answer. So we can use synthetic division, and our remainder tells us a few different things. So the remainder can tell us the value for those questions yesterday when it said evaluate at x is equal to k, and we did synthetic division. Our remainder gave us the value that our polynomial would be at that number. If our remainder is 0, then we know that that x minus k is a factor, which if it's a factor, it is also an x-intercept. In the last section, we talked about how x-intercepts, factors, and zeros and solutions all mean the same thing. So if it's a factor, it's also an x-intercept. It would fall on the x-axis of our graph. Or it would be a 0 of our graph. It's a solution. Now, sometimes it doesn't give us, like the first example where it said, determine if these two are factors or not. Sometimes we just have to find our factors from the start. So to do this, we're going to use the rational zero test or rational root test. The rational zero test, we find factors of the last. So factors of our last term are constant over factors of the first, which is our leading coefficient. So this is step 1. This gives us the possible solutions. Possible real solutions, I'll say. So doing factors of the last over factors of the first gives us our possible real solutions. They may not all be solutions, but those are possibilities. To determine if they are actual factors or not, the second thing we have to do is synthetic division. So we do synthetic division, and we need 0 to be our remainder. So need the remainder to be 0. So it's written again on the next page. So our possible rational zeros are factors of the constant term, so factors of the last, over factors of the leading coefficient, which are factors of the first. So this gives us our possibilities. We're going to take our possibilities, do synthetic division with them, and see what actually is a 0. So let's look at example 7. Typically, if we have 4 terms, we'd want to see if we could factor it. When you have 4 terms, how would we factor? Grouping. You can try grouping here, but when we group, we need the inside parentheses to be exactly the same, and it's not going to work out for this one. So it doesn't factor, so we're going to use our rational zero test, so our rational root test. We're going to find factors of our last term over factors of the first. What are factors of negative 20? Or just factors of 20. What 2 numbers multiply and give me 20? 2 and 10. So I'm going to put plus or minus 2 and 10, because it could be either sign. What else? 4 and 5. What else? 20 and 1. Awesome. Over factors of the first, what's our leading coefficient? 1. And what are factors of 1? Just 1. So we're only working with whole numbers here. So it'd be 2 over 1, 10 over 1, 4 over 1, 5 over 1, which are just all the whole numbers. So now we got to do synthetic division. So inside the box, what would go inside? 1, 8, 11, and negative 20. Our coefficients go inside the box. Now we need to test and see what works. We're going to test our possible solutions. So you can pick any one of these numbers, and we're going to do synthetic division with it and see if it gives us 0. What do you want to try first?
2.
Sure, let's try 2. I'm going to drop down the 1, multiply, add, we get 10, multiply 20, add 31, multiply 62, add 42. Does it work? No, doesn't work. So let's try something else. As soon as you realize it's not going to work, you can stop and try something else. This is just trial and error. So you just have to keep trying possible numbers. What do you want to try next? Sure, let's try 10. You can try any one of your options. Multiply, we get 10, add 18, multiply 180, add 191. Do I need to keep going? No, it's not going to work. What do you want to try next? Sure, let's try -2. Remember, the negatives are also possibilities. Multiply, we get -2, add 6, multiply -12, add -1, multiply 2. Does it work? No. Let's try 4. Multiply, we get 4, add 12, multiply 48, add 59. Is it going to work? No. Let's try 1. 1. Multiply 1, add 9, multiply 9, add 20, multiply 20, add, what do we get? Does it work? Yes. So 1 is an answer. So I'm going to say x equals 1. Now, how many answers total am I going to have here? 3. Awesome. The leading term, your highest degree, tells you how many real zeros you can have. So we have 3 answers that we're looking for. 1 is one of them. Now I can keep doing last over first with my answer that I have here, or since I started with x to the 3rd power, what's my answer going to start with? X to the 2nd plus 9x plus 20. So I can just factor this. Once you get to x squared, you can stop doing last over first and just factor. What are 2 factors of 20 that add to 9? 4 and 5. So we have x plus 4 and x plus 5. So what does x equal? -4, -5. So I'm going to add that to my solution up here. -4 and -5. So these are my 3 zeros. So once you get to x squared, you can just factor. If I would have tried -4 from the beginning as one of my possible zeros, if I would have done synthetic division with that, it would work and you'd end up with 1 and -5 when you factor. So you'll end up with the same solutions. It doesn't matter which one you find first. Now, some of the questions on the homework ask for zeros. So this would be how we leave our answer if it said find the zeros. Some of it wants it in factored form. So if it asks for the complete factorization, it's asking for factored form. How would I write my answer here as factors? Awesome. X minus 1, x plus 4, and x plus 5. So this would be the factored form of it. So depending on what the homework asks for, just make sure you read the instructions. Questions? All right, let's do the one right below it. So we want to find factors of the last over factors of the first. What are factors of 6? Awesome. So I'm going to say plus or minus 2 and 3 and 1 and 6. Awesome. What are factors of our first? Just 1. So it'd be 2 over 1, 3 over 1, 1 over 1, 6 over 1. So we're dealing with all whole numbers here, which is nice. Inside the box, we're going to put our coefficients. So 1, 2, -5, -6. What do you want to try first? 2? Is that what you said? Sure, let's try 2. Drop down the 1, multiply, add, we get 4, multiply 8, add, we get 3, multiply 6, add 0. Does it work? Yeah, so what's one of our answers? X equals what? 2. How many answers are we looking for here? 3 answers. So we got 2 more left to find. If I start with x to the 3rd power, my answer here can now start with x to the 2nd plus 4x plus 3. Can I factor this? Yeah. What are 2 factors of 3 that add to 4? 3 and 1. So x plus 3, x plus 1. So x equals what else? -3 and -1. Perfect. So I have 2, -3, and -1. So these would be my zeros. So we have to do factors of our last over factors of the first. What are factors of 12? 12 and 1, 6 and 2. Anything else? 3 and 4. Over factors of our first, which are just 1. Inside the box, am I missing any terms? No, so we can just put our coefficients. So 1, -4, -13, 4, and 12. What do you want to try first? We've got 4 possibilities. We need 4 answers. Any suggestions on what to try first? Sure, let's try 1. Drop down the 1, multiply, add, we get -3, multiply -3, -16, -16, this would be -12, -12. Does 1 work? Yes. So x equals 1. What would we do next? If we start with x to the 4th power, what's our answer going to start with here? X to the 3rd. Can I factor x to the 3rd? No, not as easily as an x squared. So what would I do next? You could try to group them. Grouping's not going to work here though. Synthetic division again. We have to do last over first again. So I'm going to do the same thing. Now I'm going to take the answer that I just found here and put it inside the box. So 1, -3, -16, and -12. When you have an x cubed and you have 4 terms, you can try grouping them, but remember when you group them, you need inside parentheses to be exactly the same. So grouping's not always going to work. If you want to try, you can try it. If it doesn't work, you have to do synthetic division. Our last term is the same, so our last over first are our same possibilities. So we're choosing from this list here. What do you want to try next? Sure, let's try 2. Now keep in mind, an answer can repeat. If 1 worked, it is totally possible that it could work again. I don't think that's the case here, but it could work again. So let's try 2. We're going to drop down the 1, multiply, add, we get -1, multiply -2, add -18, multiply -36. Does it work? Nope. As soon as you realize it's not going to work, stop and try something else. Sure, let's try -1. -1, -4. Multiply would be 4, add -12, multiply +12, add 0. Does it work? Yay, let's add it to our list. -1. Now here, we have x to what power? X to the 2nd power. So now let's factor it. Again, you can keep doing last over first if you want to, but it'll probably just be easier just to factor it if you get x squared. So 2 factors of -12 that add to -4. negative 6 and 2. Perfect. So x minus 6 and x plus 2. So x equals what? 6 and negative 2. Awesome. So I'm going to add those to my list. X equals 6 and negative 2. So these are my 4 zeros here. All right, let's do the one right below it. So we need factors of our last over factors of the first. What are factors of our last term? So plus or minus 1 over, what are factors of our first? Plus or minus 1. So we're just dealing with 1 over 1. So we really only have positive 1 and negative 1 to try, which kind of makes it easier. The less possible options you have, the easier it is. You're not sitting here all day working it out. What's going to go inside the box? No. Awesome. We're missing an x squared. So I have to put a 0 in that spot. If you don't put a 0, your answer is not going to work out correctly. So we have 1, 0, 1, 1. What do you want to try first? Sure, let's try 1. Drop down the 1, multiply, add, multiply, add, multiply. Does it work? No, didn't get 0 as the remainder, so it doesn't work. What should we try next? Negative 1, the only other possible option. Negative 1. So multiply, we get negative 1, add, this would be negative 1, 1, 2, negative 2, negative 1. Does it work? No. What do we think our answer here would be? No what? No real solution. No real solutions. We're only testing the possible real whole numbers that we have here. So there are no rational zeros. There may be imaginary zeros. We may have irrational zeros where you had square roots, but there are no real numbers that work here. This one I worked out in the last class, and we tried all of our possible options. Let's list. What are possible options of 10? 1, 2, 5, and 10. But remember, these are positive and negative. And factors of our first would be 1. We tried positive and negative 1, positive negative 2, positive negative 5, and positive negative 10. None of them worked. So just to save us a little bit of time, this one, again, is no real solutions. You have to try every single possible option before you say that there is no real solution. One important thing here is if you can't factor, so if we get to an x squared that doesn't factor, so if we have an x squared that doesn't factor, we have to use the quadratic formula. So sometimes you may only have like 1 or 2 real solutions, and then the others may be irrational. They may have a square root in them. So if it doesn't factor, you have to do the quadratic formula. I think that there's one from the homework that you have to do quadratic formula. Also, there's one in the homework, I don't know what numbers it was exactly, but something like if we had 2x cubed plus x squared plus x plus, let's say 6. If we did factors of our last over factors of the first, what are factors of our last? So plus or minus 1, 2, 3, and 6. What are factors of the first? Positive and negative 1 and 2. So it's not always going to be that your leading coefficient is 1. So when that's the case, it kind of introduces fractions a little bit. So we have 1 over 1, 2 over 1, 3 over 1, 6 over 1, which would just be 1, 2, 3, 6, and the negatives of them. But then we also have 1 over 2, which would be 1/2. 2 over 2, which is 1. We already have that on our list. 3 over 2, and 6 over 2, which is 3, and we already have that on our list. So sometimes, if your leading coefficient's not 1, and you have to list out your factors of the first, you may have fractions. So you may be doing synthetic division with fractions. I would recommend doing synthetic divisions with the whole number first, rule those out, and then maybe you might have to factor with and end up with a fraction at the end. So do the whole numbers and save the fractions for last, because you may just end up factoring with it. This one I totally made up the question, so I don't know if any of these actually work, but I think there's one in the homework where fractions are a possibility. But try the whole numbers. If none of the whole numbers work, then you have to do synthetic division with fractions. But it's just adding and multiplying with fractions, and I know that you guys know how to do that, right? We love fractions.